Okay, and we're back. All right, so hopefully you got this all figured out. We've got an isosceles triangle right here. Now, it does not by definition an isosceles triangle, but this triangle has two congruent angles, so therefore it must have two congruent sides. Remember, it's always the sides opposite of the angles. So you kind of just go opposite of wherever the angles are, and those two sides must be congruent. So in this case, I know that 8x minus 1 has got to equal 4x plus 5. Okay, and that this is a pretty easy situation to solve. I move all the x's to one side, all the numbers to the other side, and I'm good to go. So I'm going to go ahead and subtract 4x from both sides. That's going to give me 4x minus 1 is equal to 5. Add 1 to both sides, and I get 4x is equal to 6. So therefore, x is equal to 6 over 4, which is the same thing as 3.5 or 1.5. You can take this value and you can plug it back in, and you can make sure that everything works. Okay, so up here, I would say I want 8 times 1.5 minus 1. Well, 8 times 1.5 is 12. Minus 1 would give me 11. So this side right here is 11. The other one says, well, 4 times 1.5 plus 6. Well, 4 times 1.5 plus 5, not 6. Okay. 4 times 1.5 is 6. I add 5 and I get 11. And this is important because these two sides were meant to be congruent, so I've got to get the same side or the same size. And then for that last one, I have 2 times 1.5 plus 11. 2 times 1.5 would be 3. 3 plus 11 is 14. So my two congruent sides are each 11 and my base is 14. Hopefully those are the same answers that you got. All right, now we're going to take this just a little bit further, and we're going to add something that's going to seem a little bit odd, okay? And that is if you have an isosceles triangle. So let's make this an isosceles triangle. I know it's cut down the middle, but we're going to say this is an isosceles triangle. And if you bisect that top angle, now when I say bisect means to cut into two congruent pieces. So if I have an isosceles triangle and I bisect that top angle, so again, if this, then this is what happens. That bisector, that angle bisector right here, will always perpendicularly bisect the base, okay? If you have an isosceles triangle and you bisect the vertex angle, that angle bisector will always perpendicularly intersect the base and break it into two congruent pieces. So we got our new conditional we got to write. And so we're going to say if, and you might have to draw this one a little bit more carefully, if we're going to draw that triangle, we got congruent sides, so that shows it's isosceles. Cut it down the middle, say this angle is congruent to this angle. Okay, so if we have that, then what do we know? We know that that angle bisector must be a perpendicular bisector of the base. That's right. And so we know if we've got an isosceles triangle and we bisect that vertex angle, then we know that that angle bisector perpendicularly bisects the base. And we can use this with some problems. And so here's one that we can look at. And so from this situation, I want you to take a quick minute and see if you can figure out what it is you're supposed to do, okay? Because that's what we have going on here. Notice we have an isosceles triangle, two congruent sides. And notice that vertex angle, that angle that's located in between the two congruent sides, has been bisected. So therefore, this thing right here, this bisector, perpendicularly bisects the base. Okay, and so I want to see if you can answer these two questions. So we're going to take about 2 minutes, and you're going to look, let's see. Yeah, in the next 2 minutes, I want to see if you can figure out the answer to these two questions. Okay, and you're going to give that a try right now.